We've all taken math classes and asked ourselves, when am I ever going to use this? Well, I want to show you a math trick that I learned way late in school. I know it had been shown to me several times and it just didn't make any sense. It didn't finally click until like my second year of engineering school, which is way too late. But I'm going to show it to you today how I wish it had been shown to me back in high school when my chemistry teacher just kept demonstrating it and it just never clicked for me, and I want to make it click for you. And it starts with a pizza. Okay, if I ask you how many pizzas we have, it's pretty clear this is one pizza. But how about if I cut it in half? Okay, how many pizzas do we have now? It's still one pizza, even though we have two halves. So how about if I cut it again? Okay, it's still one pizza, even though it's 4/4. Okay, I'm going to cut it again. Okay, how about now? We have 8 pieces of pizza. We have 8/8, if you will, but it's still one whole pizza. So like we said, we cut the pizza in halves, but how many halves did we have? 2. So that was 2 halves, which we know is still a whole pizza. And then we cut it again into fourths. And how many fourths did we have? We had all 4 of them. And then we cut it again into eighths. And how many eighths did we have? We had all 8 of them. And all of these were still one pizza, right? Now, why is this? Well, it's because anytime you put something over itself in a fraction, it is equal to 1. So if we were talking about, let's just go to time, units of time, and we're going to say 1 minute over 1 minute equals, that would equal 1 because it's over itself. Or we could put 60 seconds over 60 seconds, and that's also equal to 1. But you know what? 1 minute is equal to 60 seconds, right? So we could even say 60 seconds over 1 minute, because these are equal to each other, and therefore all of those still are equal to 1. We could go to distance and say that, let's stick with the metric. 1 kilometer, and I could write 1 kilometer over 1 kilometer, or what is a kilometer in meters? That's 1,000 meters. And that's the same thing as, what, 1,000, I can flip it, and it's still 1,000 meters over 1 kilometer. It's all equal to 1. Now, why is this useful? Why do we care about all this stuff being, well, number one, if you've done even just some basic math, you can divide by 1, you can multiply by 1, and what does it do? Nothing. If I take 5 and multiply times 1, I still have 5. 10 multiply times 1, I still have 10. Divide by 1, I still have that same number. So if all of these things written, you can flip them around, they're equal to 1, it means I can throw it into an equation or use it with anything I want to without changing the inherent value. So let's go to the wind power videos that I'm doing right now, and the turbine is rated for 11 meters per second, but I don't really have a feeling for meters per second, and probably neither do you either. It's either you're more familiar with miles per hour or kilometers per hour, because that's what, highway speeds, we kind of have a feel for how fast that is. And so when I saw 11 meters per second, and we'll just say we're working in velocity now, working with 11 meters per second, I'm like, well, what is that in? Of course, I'm American, growing up in America. I want to know miles per hour, but let's start with kilometers per hour. So 11 meters per second, let's rewrite that as 11 meters over 1 second. I should just abbreviate that with an S. But if we want to convert this to kilometers per hour, well, we can take this and multiply times 1, and we'll still have 11, right? We haven't changed it. Well, if all this stuff, like we know that 1,000 meters is 1 kilometer, and we want to get it into kilometers, then I can multiply times, I'll put meters on the bottom and kilometers on the top. And now that I have meters over meters, those things will cancel out, and I'm left with kilometers on the top. I've converted it. I just need to write which one this is. And let's see, we go up there, there's 1. We said that 1 kilometer is the same as 1,000 meters. So now I can cancel out those meters, and I get this kilometers per second. Now I also want hours, and I have seconds. Now we can go right to, let's do this with, you may not know how many hours are, or how many seconds are in an hour, but we all know seconds in a minute. So let's put, since we want to cancel out the seconds, we'll just do S for seconds here. We're going to say seconds and minutes, and we know that there are 60 seconds in 1 minute. And now our seconds can cancel out because I have seconds over seconds. That's equal to 1, so that's nothing. But I want hours, so I'm going to come in here and say, okay, I want to turn those minutes into hours, so I'll put the minutes up here and the hours down there. How many minutes are in an hour? How many hours? What's the relationship here? Well, we know that 1 hour, 60 minutes. So now I've got minutes over minutes, and which equals 1, and 1 can just go away. So now I have left with, I've got kilometers up here and hours down there. So all I have to do is just multiply straight across 11 times 1 times 60, and I get a number on top, and I go, looks like I've just got 1,000 on the bottom, divide by 1,000, and I'm going to have kilometers per hour there. Let me grab my calculator real quick. Okay, what are we doing? We've got 11 and 60 and 60 times gives us 39,600, and then divide that by 1,000, which is obviously just moving the decimal place 3 places over, so it's going to be 39.6 kilometers per hour. Yep, 39.6. There you go, and that's how you can convert. Now, for me, being American, I keep wanting to say Kilometer pro Stunde auf Deutsch. The kilometers per hour doesn't really mean much to me. I'd rather know in miles per hour. So we can do that again. If we start over with 11 meters over 1 second, and we know that if we do this enough times of converting to minutes and seconds, that 60 times 60 is 3,600. So we can say seconds over 1 hour, 3,600 seconds over 1 hour, and that'll get us to hours immediately. But we want to get from meters to miles. Whew, that's going to be, we're going to have to do a couple of things. And all of you folks that are used to metric are going to laugh. But this is what we're taught to do. In an engineering school, the professors would have us do this just back and forth on tests, and you just got good at it, okay? And it's really handy, which I'll show you at the end here for little math things that you want to do when you don't even have an equation. You can use the units to figure it out. So we're going to try to get from meters to miles. And the one that I know in my head, I mean, it's going to be about like 39 point something, a lot of decimal place inches in meters. But the number that converts really well from meters, from metric to imperial, is this 2.54 centimeters in inches. And so I'm going to go from meters to centimeters. 1 meter is what, 100 centimeter? I should have written cm. Sorry about that. 1 meter is 100 centimeters, so I get to cancel out my meters. Now, put centimeters on the bottom, and there's 2.54 exactly centimeters in 1 inch. Okay. Now there are, put inches on the bottom again so it can cancel out, and we're going to go to feet, because I know how many feet are in a mile. There's 12 inches in 1 foot. And then there are the number of feet in 1 mile is 5,280. That's something every school kid learns here in the US, is how many feet are in a mile. Now what have I done here? We've got inches and inches can cancel. Feet over feet cancels. We're left with the mile that we want. Centimeters, if I'd written centimeters properly, that cancels. And so we are left on the top, on the numerator, we've got miles. And in the denominator on the bottom, we've got hours, so miles per hour. We have converted this from meters per second to miles per hour. And so what are we going to do to get, whatever we multiply out of here, we'll have miles per hour. So what do? We go 11 times 3,600 times 100. It's all ones after that. And we go into the denominator and we go 2.54 times 12 times 5,280. So let's do that real quick. 11, 3,600, 100 times, woo, that's a big number. 396 with 4 zeros after it. And then on the bottom it is 2.54 times 12 times 5,280, which is also a big number, 169.34.4. Divide those, and I get 24.6, and we'll say mph is really common here in the States. So that's a very common speed for residential areas, 25 miles per hour. So that has meaning for me, because I don't go up and drive around in Canada very much. I've done it a few times. But that is how we convert units. And I mentioned that this is really useful. And like as a kid, we're driving cross country or something, and it just seems like it's taken forever. Gee, are we there yet? Are we there yet? And I tell my kids, we'll figure it out. You can use this unit conversion stuff to figure it out, that if we have, and we'll switch back to kilometers again, that if we know from the map or signs on the road that it says 400 kilometers to Dusseldorf von, wherever, Köln or whatever town it might be, You have 400 kilometers to go, and let's say you're able to travel 100 kilometers per hour. Well, now wait a minute. If I try to multiply this out, I'm going to end up with kilometers times kilometers per hour. That can't be right. So we need to flip this. 100 kilometers in 1 hour. Let's just flip this over, and we're going to say 1 hour is 100 kilometers. Okay? Now the kilometers cancel, and I've got 400 divided by 100, and it's going to be 4 hours. So I know if we're traveling 100 kilometers per hour for 400 kilometers, that's going to take 4 hours. Now, let's say it's the Autobahn the whole way, and we're going 200 kilometers an hour. All I have to do is throw that in there. Now we're dividing 4 by 2, and it's 2 hours to go that far. And it's the same thing in miles per hour. The easiest one, when there's 60 miles to go, and we know that we're traveling on the highway, and okay, the speed limit's 55, but we're going to go, the flow of traffic is 60 miles an hour. I'm not going to put the miles on top, and I'm going to put the miles on the bottom so that it cancels. 60 miles, 1 hour, the miles cancel, and I'm left with 60 divided by 60. It only takes me 1 hour to get there. And we could do the same thing. 120 miles would be 2 hours. But, you know, get your calculator out and you can start doing hard numbers that give you lots of decimal places, and it'll tell you exactly how far you have to go. So this is working with units, and this is probably the most common thing as an engineer. You end up with a torque, and you're trying to figure out how big of a motor, how big of a stepper motor that I might need when I'm retrofitting my old manual milling machine, and I measure the torque that it takes, and maybe the torque wrench is only in foot-pounds or Newton meters, and the stepper motors are rated in ounce inches or something like that. The only way to compare them is to be able to figure it out like this. And yeah, there's online calculators if you can get on there that'll do direct conversions for you. But you never know if you've gotten it flipped the right way or not. It's nice to be able to do a conversion, converting pascals to pounds per square inch from PSI, that kind of stuff. So I don't know why this didn't click for me when it was shown to me in high school chemistry, but the teacher just kept doing examples over and over again, and I never quite got this, oh, if you put anything over itself, then it's equal to 1, which means I can take that and multiply it in anywhere I want without changing the value, as long as I'm tracking the units all the way through. So hopefully this was helpful to someone. This is something that I wish I had learned much, much earlier. My grades would have been much, much better, much, much sooner. And so hopefully this is something I've been wanting to do for a long time. Here's the video. Hopefully it's helpful to you. If you know the name of this, whatever this principle is, I think it's a mix of things like identity principle, unity principle, that kind of stuff. If you know what this is called, please go in the comments and tell me, so I can tell other students when I'm talking to them that so I don't have to call this just working with units or something. So and yeah, tell me if this was helpful for you, and when you learned it, and if this slowed you down at all. So that's all I've got on this. I've got lots of other math little tricks planned that I want to show, including all the way up to calculus and how simple calculus can actually be. I just got to find time to sneak these in while I'm waiting for parts to show up for the other bigger channel. That's all for now. I'm Quint. Thanks for watching.